Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you framing at data link layer. So before I explain you this topic, let me tell you how many things that I'm going to cover in this video. See, first I'll be explaining you how frames are produced by data link layer. Then I'll explain you what is the basic format which is there with frame. Then I'll explain you two types of framing. One is fixed size framing and second is variable sized framing. Then I'll explain you bit stuffing concept in frame, and then I'll explain you how we can solve problem based on bit stuffing in frame. So let us have first concept over here, that is based on how frames are produced by data link layer. So here if you observe, OSI model is there. So layer by layer data is getting modified in sequence and data link layer will be producing frames. So first of all, you can consider in this way, you are using a computer, so you will be using application. So by using application, you will be requesting for some data. That data may be text data, that data may be image data, that data may be video data. So data will be requested by user from application. Now that data request that will come at output of session layer. So session layer that will be having output, that is data. That data may be text, it may be video, it may be image. Now as if I say you are having video data which is having size of 1 GB. So 1 GB frame, that is too large frame. You cannot send size of 1 GB frame. Obviously size of frame will be small, right? So first of all, we need to bisect this large size data into segments. So that large size data that is getting bisected into segments, and that is happening at transport layer. Now in segments, there are some basic information that we are giving, like what is segment number. So first information, that is what is segment number, and second is what is port number, right? So in segment, two information will be there, segment number and port number. Segment number is a sequence number, but port number explains you which process is happening. Like as if you use YouTube, then with YouTube, there is well-defined port number. So in your computer, there is a process which is happening. And for that process, there will be well-defined port number. Like for example, if you use Skype application, then for Skype application, well-defined port number will be there inside your computer for that process. So port number is associated with process and segment number is a sequence number of segment. So data is bisected into segments at transport layer, and these segments will be given to network layer. Network layer will be forming packets. Packets means along with segment, network layer will add IP address of source and destination. So you will be having packet, that is segments plus IP address of source and destination. IP means internet protocol. So IPv4, IPv6, this type of IP addresses are there, as well as routing algorithm that is there at network layer. Now those packets that are output of network layer, that will be given to data link layer. So data link layer that will be producing frames. Now that frames that will be having what information? This packet which is forwarded by network, then this packet plus MAC address of source and destination, means physical address of source and destination, that is added by the data link layer, as well as it will be adding some tail bits. So in tail bits there are some informations like what is CRC, what is checksum, right? So this CRC and checksum, that we use it for error control. So data link layer that is having two information over here with frame. One information is there regarding physical address, and second information that is there regarding error correction by CRC or checksum, right? So physical address that is there with respect to source and destination, right? So transmitter and receiver physical address that is given over here by data link layer. You can say physical addressing is done by data link layer, and IP address that is given by network layer. You can say logical addressing that is done by network layer, right? segmentation that is done at transport layer. Segmentation means you are bisecting data into small segments. So port number means which process is there with given segment, as well as what is the sequence number of that segment, that is given at transport layer, and data initiated by this three layer, right? So that is how things are there. Now if you observe this complete structure, then there are varieties of protocols which is happening. Like at application layer, HTTP, HTTPS, SMTP, right? For email, you will be using SMTP protocol. For browser, HTTP, HTTPS that you will be using. In presentation layer, for image, JPEG protocol will be there. For video, MPEG protocol will be there. For security, SSL protocol will be there. At transport layer, TCP, UDP protocol will be there. At network layer, routing protocol, IP protocol will be there. At data link layer, media access control, error control, flow control. At physical layer, we'll be having signaling, encoding. Signaling means for electrical signal, you will be having Ethernet cable. For optical cable, you will be having light signal. For wireless communication with Wi-Fi, you will be having radio waves. So that comes under signaling. Encoding means NRZ, RZ, Manchester. So all those protocols that comes under physical layer. So in short, if you observe how many data that is there with one frame. So details of protocols, IP address of source and destination, physical address of source and destination, segment, for error correction, CRC, checksum. See, that many informations are there. So frame format is not fixed. That also depends on protocol, right? Frame format is not fixed. That is also depends on protocol. But as if I want to explain you frame format, then in layman term I can tell you like there are three sections. One is header, second is data, and third is tailor. In header, you will be having start of frame, or you can say start delimiter. See, this start delimiter that explains you starting of frame. Like you see, initially you will be giving some pattern, that is start of frame. Like you may send 0 1 1 1 1 1. So this initial data that indicates from here onwards we are starting our frame, right? Similarly, after tailor, you can have end delimiter, or you can say end of frame. So in that also fixed pattern, like 0 1 1 1 1, fixed pattern that we are adding. So that indicates from here onwards we are starting the frame, and at last we will be saying like, okay, this is where we are ending our frame. So that comes under header and tailor. Frame number will be there inside header. Frame size will be there inside header. Like in Ethernet, frame size will be given. Protocol details, I have told you there are varieties of protocols, right? MAC address of transmitter receiver, IP address of transmitter receiver, that will be there inside header. When it comes to tailor, you can have CRC or checksum, that is for error control, as well as end delimiter that I have told you. And then in between there will be data, right? But see, this is generalized format. For basic format that will vary with respect to protocol. So in future I'll explain you how Wi-Fi LAN frame format is there, how Ethernet LAN frame format is there, how token ring LAN frame format is there. So that I'm going to explain you in next coming videos. So that format of frame that will change a little bit, but you should be having idea about what is the basic format. So header, data, and tailor, right? Header will be having some data, tailor will be having some data. So basic format that should be there in your mind first. Now I'm going to explain you how many types of framing that is there. Like fixed size framing. So from name itself you can understand size of frame that is fixed, right? So transmitter and receiver both are agreed upon a protocol in which they are having idea about, okay, transmitter will be sending 100 byte of frame, receiver will be receiving 100 byte size of frame, right? So fixed size of data will be there with frame. While in case of variable size frame, you will be having variable size, right? So transmitter and receiver both are not agreed upon finite data, right? Means data length may be different. Like if you observe here, this data length, so that will change over here with variable size frame, right? So how to identify that? That is a bit interesting. I'll explain you how to do that. Now see, when it comes to fixed size framing, in that frame size that will act as a delimiter. So it doesn't require boundary bits like start and end of frame. Like if you observe here along with header I have shown like start of frame, end of frame that we need to add, right? But with fixed size framing you don't need to have it. Why? The reason is transmitter and receiver have agreed upon a principle in which size of frame is fixed. So why you are adding redundancy? Already both are knowing like this is how they are starting a transmission and how they will be receiving as per fixed size. So there is no need of start of frame and end of frame with fixed size framing, right? But here there is one issue. See, if data to be transmitted is lower than fixed size, then padding bits will be added. Let me show you. This is very essential. Like as if you are having a frame that is having fixed size like header, tailor and data is there, right? Now if you say this size is fixed 100 bytes, right? But right now if I say you are having only 77 bytes as per header, data and tail, then what will happen? Here you will be adding padding. You will be adding padding. So you will be adding padding. Padding means string of zeros or string of ones. See, redundancy that you will be adding. Why? The reason is transmitter is having less number of data compared to fixed size. So obviously transmitter will have to send 100 byte size frame. Transmitter cannot send 77 bytes as fixed size framing is there. So in that padding will be done. But to avoid issue of padding, you can go for variable size framing. So in variable size framing, size of frame will be different. Size of frame will be different. But here there is a need of identification of start and end of the frame. Remember this. In variable size framing, there is a need of identification of start and end of the frame. So that identification that could be done by two ways. One is by providing length of frame and second is by providing delimiter like start of frame and end of frame. If you provide length of frame like we provide that in Ethernet protocol, then one can have an idea about okay, what will be the end of my frame. But if you don't provide length of the frame inside frame format, then you don't have idea about at which location frame is getting end. So for that you'll have to provide what? Start of frame and end of frame. So start of frame and end of frame that is provided in case of token ring protocol. But if you provide size of frame inside frame format, then you can say okay, how that frame is getting ended, how that frame is getting terminated as it is happening in Ethernet protocol. Now very interesting concept that I'm going to explain you, that is bit stuffing. See, bit stuffing that is very essential when you add some extra information like start of frame, end of frame, right? Now first of all you need to understand what is the problem. Like in variable size frame, end delimiter that is used to terminate the frame. You can observe here end delimiter that I have added. So that is 0, 1, 1, 1, 1, 1, right? That is end delimiter. This is what we are using it to terminate the frame. Now what if that pattern, what if this pattern that comes in the data, then there can be issue. Like you see, first of all what transmitter and receiver is doing. See, transmitter and receiver both are agreed upon a protocol. Both are agreed upon on a protocol. That protocol indicates end delimiter. That protocol indicates end delimiter that is equals to 0, 1, 1, 1, 1, 5 times 1s are there, right? So here whenever transmitter is sending bits over here in sequence, and as if this pattern is coming at receiver side, then receiver will be saying like okay, this is what end of frame, this is what end of frame. So receiver will be terminating that frame. But what if this bits come somewhere in between data? Then you can say there is a false detection of termination of frame, right? The reason is transmitter and receiver both have agreed upon a protocol that says end of delimiter, that is this. So if receiver receives this bit somewhere, then receiver will be saying, okay, I have received the frame successfully. It will terminate it, right? So whenever transmitter is sending the data, at that time, that data manipulation that should happen. Otherwise, you see here what is happening in section of data. In section of data, you see 0, 1, 1, 1, 1, 1. 5 times ones are coming. So here what will happen? After receiving these bits, receiver will say what? End of frame. Practically end of frame is happening over here. So false detection is happening. And we can avoid this by having a bit stuffing.
Hello, Hitesh sir. Can I ask you one question?
Yes, Mansi, definitely you can ask question.
Sir, if end delimiter comes into data part, then it will terminate frame at false time, isn't it?
So that is what the case which I am going to explain you over here. Let me explain you how we can resolve this issue. So here, bit stuffing, that we use it to avoid false termination of frame. Let me show you how. See, for example, if I say I'm having a bit string, as it is mentioned over here, 0, 1, 1, 1, 1, 1, 1. Right, that is how data is there. Now let us say transmitter and receiver both have agreed upon 0, 1, 1, 1, 1. Let us say both have agreed upon end of frame as per 0, 1, 1, 1, 1. Right. Then what transmitter will do? Transmitter will see, okay, right now transmitter is sending data. So transmitter will see 0, 1, 1, 1, and before last one over here it will be adding redundancy. So what it will be doing is, as if this is the data, then transmitted data will be 0, then 1, 1, 1. Once it receives 3, 1, by default it will be adding 0. So this is what bit stuffing. Right, it will be adding 0 before it gives next data. Right, even if here there is 0, then also it will be adding this 0 over here, right, as per this is end of frame. Now what will happen? You see, after that there is 1, 1, 1. So 1, 1, 1. So this is what transmitted data now, right? So as if you insert 0, as if you insert 1, 0 over here, then it could have resolved the issue of false termination over here, right? So that is what we do it in bit stuffing. Let me give you one practical example so that will give you more clarity. So here, if you observe, bit stuffing based framing protocol uses 8-bit delimiter pattern of 0, then 6 times 1 and then 0. So here, if you observe, end of frame delimiter that is given, that is 0, then 6 times 1s are there, then 0. Right. If output bit string after stuffing is this, then input string will be, so you should know first of all, whenever transmitter is sending data, then it will be observing this pattern carefully. And at this location, you see, continuous ones are there. So after 5th location, in data, after 5th location, it will add 0 at this location, right? So what will happen? You see, if this is the data, that is output data, right? This is the data, that is output data. Let me write it. 0, then 5 times 1s are there, then 00, then 1, 0, 1. This is what output data. But that output is generated by adding 0 somewhere over here, right? In between these two ones, see, after 5th one, by default it will add 0. So you see what will happen here? As if pattern is like this, 0, 1, 1, 1, 1, 1. So after 5 ones, it could have added this additional 0, right? So you can say this is what bit stuff over here. So at input side, You can say this is what additional data, right? So this is what you'll have to eliminate. So actual data of input, that could be 0, then 5 ones, then 0, 1, 0, 1, right? So this is what the actual data, that is input data. And this 0 that we are adding to avoid false termination, right? So you can say your correct option, that is this over here. So once you understand this question, like what is bit stuffing, then you can easily resolve questions based on it, right? But first of all, concept should be very clear. If anything that you would like to ask over here, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.